We're going to talk about combining rational expressions with addition and subtraction today. Just a refresher that a rational number is any number that can be written as a fraction. And then a rational expression has variables in it. So it might have variables in the numerator, which is the top of the fraction, might have variables in the denominator, the bottom of the fraction, but somewhere. And the key to adding and subtracting fractions, whether they have variables in them or not, is finding a common denominator. We have to have a common denominator whenever we add and subtract. Now, we're not going to talk about multiplying and dividing this year, but multiplying and dividing fractions do not have to have a common denominator. Only adding and subtracting have to have a common denominator. And as we look at a couple of examples here, I better talk about one sentence here. To add or subtract fractions, we have to have a common denominator. We can only change denominators by multiplying the overall fraction by 1. Sometimes what we say is it's a fancy form of 1. But as we look at this, I'd like to do these without a calculator. And in fact, the first one we could type into our calculator, but the second one we can't. Even the good calculators, you cannot type in an X for a denominator. So what we have to do when we find a common denominator is, at the very least, we can multiply we can multiply the two denominators together. 3 times 5. Well, 3 times 5 is 15. That's going to be our common denominator. That always works. It just might not always be the least common denominator, which is what we like to do when we're working with fractions if possible. Well, what happens is we took 3 and we multiplied it by 5 to get 15. And because we multiplied the bottom of the fraction by 5, we have to also multiply the top of the fraction by 5. It's the same idea on the second fraction. We multiplied 5 by 3 to get 15. Since we multiplied the bottom of the fraction by 3, we also must multiply the top of the fraction by 3. So if we multiply, 2 times 5 is 10 over 15. 4 times 3 is 12 over 15. And when we add fractions, now that we have a common denominator, we only add the numerator, the top of the fraction. And 10 plus 12 is 22 15ths. You do not need to convert it back to 1 and 7/15. You can, but you don't have to. So that's the idea that hopefully you learned a long time ago. Probably in elementary school, maybe in Willis, or both. If you went to Delaware City Schools. Not sure what year it was for St. Mary's. But the idea is the same here when we do have a variable in the denominator. We're going to multiply x by 8 to get our common denominator. And x times 8 is 8x. We're going to subtract. Well, in order to subtract, we need to figure out what goes on top there. What did we multiply x by to get 8x? Well, what we multiplied x by to get 8 is we multiplied by 8. So we're going to put that 8 into the numerator. Times 7. Over here, on the second fraction, what did we multiply 8 by to get 8x? This time we multiplied by an x. That 3 is still in the numerator. So we can simplify. 8 times 7 is 56. 3 times x is 3x divided by 8x. all over the common denominator. And in fact, that's as much as we can do to that problem. We cannot simplify any further because we cannot factor any part of that fraction. So again, to add and subtract, fancy form of 1. We're going to make it a little bit more complicated here, although maybe not quite so much so on this problem 1. What we have to do is we have to add it together. But to add or subtract, we have to have the common denominator, and luckily enough, we have common denominator already. So we can add 3x squared plus 5x minus 2 plus x squared plus 4x plus 4 all divided by 4x plus 1. Well, now we can combine like terms. One thing to watch out for. Remember that that number in front of the x squared is 1. So we've got 3x squared plus 1x squared is 4x squared. We have 5x plus 4x, which is 9x. And we have negative 2 and positive 4, which is positive 2, all divided by 4x plus 1. Well, the question is, are we done at this point? And maybe even the second question is, can we factor anything in this problem so that we are done? Matthew? Let's split the middle up here in this top. Remember, we're going to take A times C. And I'm going to write it off to the side here, at least I'm going to try to save a little bit of space, although I think that I left enough space on the paper. 4 times 2 is 8, and the factors of 8 are 1 and 8 and 4 and 2. Will either of those combine to be 9? And hopefully you're saying yes, 1 plus 8. So this becomes 4x squared, and the plus 2 there, we've split the middle. It's going to be plus 1x plus 8x. And then we're finding our greatest common factor. And the greatest common factor in this first group is x. And 4x squared divided by x is 4x. 1x divided by x is 1. We had 2 x's, we took 1 out. We had 1x, we took it out. Over here in our next group, our greatest common factor is a 2. 8x divided by 2 is 4x. 2 divided by 2 is 1. And now we've gotten this far enough that we can rewrite 4x squared plus 9x plus 2 as 4x plus 1 times our singles here, x plus 2. And that's still all divided by 4x plus 1. Do we have anything exactly the same in the top and in the bottom? We've got a 4x plus 1. 4x plus 1 divided by 4x plus 1 is 1. And we've got our final simplified fraction when we added them together of x plus 2. Now, we were lucky on that one. We had a common denominator. But when we look at the next problem, I don't think that we have a common denominator. And we don't. We have to find that common denominator. And in order to identify the common denominator, we're going to have to factor. But on the first fraction, there's nothing that factors. And the numerator here in our second fraction doesn't factor. But what's the GCF in our denominator of our second fraction? And hopefully you're thinking 3. we can factor out a 3. 3x divided by 3 is x. 6 divided by 3 is 2. And now we can identify what the common denominator is, so that we can eventually here add these two fractions together. And what we see in each of the fractions is each of them has an x plus 2 in it. And consequently, because they each have an x plus 2 is going to be part of the common denominator. But the other thing, for lack of better words, in the denominator is a 3. And it's only in one of the denominators. So to make them common, what we're going to do is we're going to have to put the 3 into both. We're going to put the 3 into both. Well, if we take a closer look here on the second fraction, we didn't change anything. There was 3 times the quantity of x plus 2 originally. There's still 3 times the quantity of x plus 2 with their common denominator. So this second fraction is going to remain the same. It's 4x plus 5. But did we put anything into the first denominator that wasn't there already? Well, there was an x plus 2 there already. We put into that denominator a 3. And I wish that I would have changed that number there, but there originally was a 3 already there. So the red 3 is the new part. Don't cancel anything out. The red 3 divided by the black 3 is the fancy form of 1. And now we can combine these. We can add these fractions together. Remember, when we add them, we don't do anything to the denominator. We're going to leave it as 3 times the quantity of x plus 2. We go back here. 3 times 3 is 9, plus 4x plus 5. And then we look and see if we have any like terms. Well, 9 plus 5 is 14, plus 4x, divided by 3, times x plus 2. And the question at this point is, are we done? And as we look at the numerator, we can factor the numerator. What's the GCF of the numerator? 2. If we factor that, 14 divided by 2 is 7, and 4x divided by 2 is 2x. Do we have anything exactly the same in the top and the bottom? No. So you can leave your answer as 14 plus 4x over 3 times the quantity of x plus 2. Or you can write 2 times the quantity of 7 plus 2x over 3 times the quantity of x plus 2. Either one of these is a correct value for our added fraction. So let's take a look at another one. 5 over x plus 10 plus 4x divided by x squared plus 12x plus 20. The first thing that we need to do is we need to factor. And the only place that we can factor is x squared plus 12x plus 20. I recommend that you write off to the right of this so that we can put underneath our common denominator and do all the work underneath the fraction. But we're going to take our a times our c. 1 times 20 is 20. The factors of 20 are 1 and 20, 2 and 10 and 4 and 5. Will any of those combine? Either add or subtract to be 12? Which one? 2 and 10. And they both happen to be pluses here, so that makes life a little bit easier. We're splitting the middle. And we're going to put plus 2x plus 10x. And Now we're going to look. What's the greatest common factor in that first group? And hopefully you're thinking x. And our greatest common factor in the second group, between 10 and 20, is 10. And now that we factor that, let's put it back in. I know I haven't finished the factoring, but I'll have it finished when we put it back in here. The 5 divided by x plus 10 plus 4x divided by our x plus 2 from each group and our x plus 10 that's left over. The single x, the single 10. When we're finding a common denominator with a variable in it, what we need to do is we need to figure out, do we have anything that's in both? And what we have that's in both is x plus 10. So that's going to be part of our common denominator. Then what's not in both? Well, x plus 2 is not in both. And what we have just done is we've determined the common denominator. Now we need to ask ourselves, did we put anything into the denominator that wasn't there already on that first one? 5 was already there. Did we put anything in? Well, we had an x plus 10. Now we have x plus 10 times x plus 2. We put in an x plus 2. In our next fraction, we had an x plus 2 in the denominator. We have an x plus 10 in the denominator. We didn't put anything into the denominator, so we don't have to put anything into the numerator. We just need to keep it as is. Keep the fraction like it was. But we can combine now. We get 5x plus 10 plus 4x. The 5x plus 10 was from the distributive property. Down here in our denominator, x plus 10 and x plus 2. If we combine like terms in the numerator, we've got a 5x and a 4x, which is 9x plus 10. The only question remaining is, are we finished or do we need to do a little bit more? So in other words, can we factor 9x plus 10? No, we can't factor 9x plus 10, and because we can't factor 9x plus 10, we are done. Here is what those two fractions add to be. But as we look at problem number 4, I'm going to switch over to subtraction. And the nice part about problem number 4 is that we have a common denominator already. But I do need to stress something in this problem. When we subtract this, we already have a common denominator, so we're good there. It's going to be 3x plus 7 minus this entire numerator. That minus sign applies to the entire top of the fraction. Consequently, we need to distribute that negative here and here. So we have 3x, well, let me write it. 3x plus 7 minus x minus 3, all divided by x squared minus 4. Combining like terms, 3x minus 1x is 2x, 7 minus 3 is 4 divided by x squared minus 4. Once again, the question is, are we finished? Or in other words, can we factor anything now? And we can factor. We can factor out a GCF of 2 in the numerator. And in the denominator, it's going to be the difference between two squares. Difference between two squares, different signs. Do we have anything exactly the same on the top and on the bottom? And we've got an x minus 2. X minus 2 divided by x minus 2 is 1. And we get 2 divided by x plus 2. As we flip our paper over, we need to find the common denominator. And the thing is, we have x minus 3 in one denominator, x minus 1 in the other. The only way that we can get a denominator with these variables is we can multiply the two denominators together. And that will work every single time. Sometimes it won't be the least common. But we can't factor x minus 3. We can't factor x minus 1. We do need to be really careful because we're subtracting. And then we can ask ourselves, did we put anything into our first denominator? Well, we had an x minus 3 originally in there. Now we have x minus 3 times x minus 1. So we just put x minus 1 in there. The 2 is already there. Once again, ask yourselves, did you put anything into the denominator that wasn't there in the first place? In our second fraction, we have an x minus 1. Now we have x minus 3 times x minus 1. We put into the denominator an x minus 3. Our 1 was already there. I'm going to show an extra step. I think that it's worth writing. It's not going to be worth points. But what we have now is we have 2 times x minus 1 minus 1 times x minus 3 all over our common denominator. And I think that it's worth writing that step. It does seem to be kind of an extra step. But when we write the step, we know better to distribute the minus sign in the middle. So we're going to distribute. And we get 2x minus 2 minus 1x. Negative 1 times negative 3 is positive 3. All divided by x minus 3 times x minus 1. When we combine like terms, up there in our numerator, 2x minus 1x is 1x. Negative 2 plus 3 is 1. And then we have an x minus 3 times an x minus 1. Do we have anything exactly the same in the top and in the bottom? We don't have anything exactly the same in the top and the bottom. We cannot simplify that anymore. So to finish, I may or may not get example 7 done in our video, but we'll get 6 done in the video. Always look to see, can you factor? And in this particular case, we can't do anything with x divided by x minus 3. But we can do something with x squared minus 9. It is the difference between two squares. X and X, 3 and 3, difference between two squares. And once we factor, we can identify easier the fact that we do have something that's in both denominators. In this case, there's an x minus 3 in both of them. So that's going to become part of our common denominator. But once we determine that, we need to look and see what's in any other denominator. Because if there's something in one, in order to make it common, it has to be an odd. And we've got an x plus 3 in the second fraction, so we're going to have to put in x plus 3 into the denominator. Again, let me emphasize the fact that we're subtracting. That's why I've changed that color. And when we do this here, we had an x already in the numerator, but did we put anything into the denominator? Well, we put into the denominator an x plus 3. So we need to also put it into the denominator as well. Fancy form of 1. X plus 3, x plus 3. X plus 3 on the top, x plus 3 on the bottom. We did not change anything in the second fraction. So, we can distribute. X times x is x squared. X times 3 is 3x minus 18 divided by x minus 3 times x plus 3. And the question that we always ask when we get to this point is, are we done? And we are not. And as I'm running out of time here, I do want to say that we can factor the numerator. I'm not going to show my work to show that. But we can factor the numerator, and it's going to be x plus 6 times x minus 3. And I did not show any work on that. You would have to go back and split the middle. But do we have anything exactly the same on the top and the bottom? Well, we've got an x minus 3, and we've got an x minus 3. So our final result here is x plus 6 divided by x plus 3.